Okay, so good afternoon. I am Anto Briarjo. Welcome to Monday Live. This is something that we do every Monday afternoon at 3 p.m. Eastern to figure out really what's going on in smart buildings and how we can make them better, how we can make them smarter. So profiles of this group is on mondaylive.org. The most important thing here is to point out that the views expressed on this show here are personal, not of any company or organization. And please do make this an interactive session with chat and Q&A as you see fit. And just a reminder, this deck is on mondaylive.org if you want to see any of the links or just want to see any of this. So in January, our focus is on the Division 2525 specification that this group is working on in collaboration with the coalition and other people as well. And the agenda for today, our normal chit chat, what's going on, and then we'll talk about 2525 specs. And we want to focus this week on sort of the areas of interoperability and cybersecurity and sort of the more infrastructure-ish parts of the 2525 spec. And hopefully we can have a really good discussion. We do really want to get your input from the audience, so please do chime in as you have been doing for the last few weeks. But before we get into that, hand it over to Ken. What's going on in your world, Ken?
Thank you very much, Anto. Okay, we've got our January issue online, Defining You in 2022. It's going well. We've been hard at the last week trying to put together our Vegas sessions. Vegas is on. Everybody we're talking to is very positive. The sessions are coming together well. We're trying to firm up who's going to be live. And I think one of the big advantages with having the hybrid approach is that people can do all their planning and then make that decision as to whether they can do the face-to-face. And it seems to be that a lot of folks are making that decision that, yep, they're comfortable with the face-to-face. So that's working out well. So I think the whole event is very much an evolutionary event, and we're going to see a lot of things fall out of it. And for me personally, I just special thanks to Scott Cochran and all the folks in Scotland out there in Detroit that have helped us put this together. He has, I think, really stepped up. A lot of my approaches over the years have been kind of monoptic and haven't really reached out to enough people, but he has greatly increased the quality and quantity of speakers, as has Marc in his session too. All the sessions are greatly improved from the past automated buildings sessions. So I'm extremely pleased with that. We had an article with about the adaption, and as you know, I'm always striving to grow younger. So there I am as a tadpole with legs. Hadn't quite imagined going back that far, but so I've got some evolving to do. But I think we all have some evolving to do. There's a lot of changes, a lot of out of this confused seas in the last few years comes rapid evolution and a new world. And I truly do believe that. And so we've got to hurry up and get on with SOS, which is a system of systems. And I don't know if you happen to see this, if you haven't seen these 500 drones flying above the Sydney Opera House, it is something to see. And if you kind of just roll your eyes back and imagine that's 500 buildings responding to a grid event, it kind of tells you where we've got to get very quickly. So that's if you click on that link below, you can actually see it if you did miss it. Also, it feeds very well into Anto's article, The Road to System of Building Systems. And he's going to talk a little bit about that in Vegas as well. So I think that's a good feed in. So a lot of change, a lot of evolution required by the industry. Back to you, Anto.
Thank you, Ken. And we'll be talking about system of systems again later on this show. Moving on now to John.
Yeah, commenting on I would say, mixed messages that you read about the impact of COVID on the commercial real estate market, and whether it's up or down, and people are buying buildings or selling buildings or rationalizing space or whatever. So this week, saw some headlines here I thought was interesting. Demand for downtown apartment properties, that was key, because it was at the beginning of this, it was a big belief people would leave cities, go to the suburbs. And then recent high profile deals investing in office properties. Obviously, they believe there's going to be a comeback, and those would be good investments. So this week, two data points I saw are among all the noise out there in the direction of the real estate market, the commercial real estate market, and downtown properties coming back.
Okay, great. Thank you, John. David Katz just posted a comment about ASHRAE sessions, just clarifying whether they're going to be virtual, going back to Ken's comments. So my understanding is AHR itself is officially not virtual in any way. Although the track that the automatedbuilding.com track has virtual elements of it, because Scott made it that way. So there is, it officially is not a virtual event. Is that right, Ken?
Yes, that's correct. Also, the thing I might point out is the actual ASHRAE meeting has a virtual component. I was quite surprised at that. But AHR is they're trying to hold the face-to-face.
Right.
We have some of our folks coming in virtual, and as I say, it's actually turning out extremely well. As we're starting to organize these, we pretty much have got a room full of speakers. That being said, there is a virtual component to it, but it's not going to be, it's by invitation only.
And hopefully we'll have more on that next week.
Yes.
When we talk about that. Great. Thank you. Thanks for the clarification. Mark, over to you.
So I wanted to share two things this week. So one is this new research, I guess, from Verantex about the question is, to what extent do you use near real-time occupancy sensors? And if you kind of look at this number, this is, we've been our industry has been talking about sensors, occupancy sensors, building owners have, system integrators have. And looking at the numbers, I got to tell you, I was a little taken back by the numbers, in that if you look at these, 34% again of this particular survey or this poll have not implemented anything as of yet. 2% has only done it at relevant sites, and 16%, yeah, that's a decent number, multiple locations, and so forth and so on. But to me, is this showing something that we're not seeing, that the implementation of sensors is actually not as robust or brisk as we anticipated for occupancy, not indoor air quality. So I thought that was interesting. So you want to move on to the next, unless anybody got any thoughts, comments on this one?
Still
Seems
40%,
very...
I guess. I guess it's still 40%, Mark, that weren't there before.
Yeah, I guess that's a good way to look at it then, which I did not look at it that way, but still, why isn't this at 75, 80%? I guess.
Did they have any definition on what the occupancy sensors were, Mark? I mean, were they like motion sensors?
They may
or
have.
cameras?
I just grabbed this at the last minute, so I can't.
Yeah.
I can't say yes or no, though. But that is a good point. So anyway, you want to move on to? Go ahead.
Yeah, I was wondering about that. I was wondering if this is all sort of mostly IoT kind of stuff, but
yeah,
let's move on.
So this next one is, again, with the increase of COVID and everything else, what I thought about was interesting about this is that the inability to get tested and so forth and so on is inhibiting the return to the office. And I think that's not a surprise, but the fact that that is having a measurable effect of people returning to the office in some sense of normalcy. And then also how the price of N95 and KN95 masks have really hit the roof. And I will say this, for our team, we're going to ASHRAE, and we had ordered, in this case, Link Spring branded mask, your typical cloth mask or whatever, and met certain standards. But we now have gone back and got KN95 masks, and all of our team will be wearing those, and we paid out the yin yang for them. So as compared to several years ago.
Just to add to that, Mark, I did some own research too, a little bit on that. One of the other challenges, there's such an influx of fake, phony N95, KN95s from China coming in. You know, I saw one the other day that was a Honeywell branded one. You know, I mean, the guy was pointing out the logos aren't even right and properly aligned and a whole bunch of stuff. So, which is adding to the problem.
Yeah, good point.
Okay, thank you, Mark. So before we move on, any other perspectives or anything else anybody want to bring up?
Just one thing you might you might want to watch what's going on here in the UK. They're relaxing all the travel stuff. By the end of the month, you've only got to have a lateral flow test two days after you return. No other restrictions, and they're all almost talking about completely moving all COVID restrictions by the end of the month. The cases have dropped from something like over 200,000 a day to way under 100,000 now, and I think they're kind of looking, saying, okay, is this now the endemic? You know, are we now seeing the end, and we've reached a plateau of where we can expect, like the flu, just to continue on now? And then it'll be a personal choice. So be interesting to watch that.
Yeah, I saw the comment from, I think, the WHO that thought that 50% of Europeans will have Omicron soon or sometime in the next couple of months. So definitely things are changing.
Yeah, I think we're definitely on the slope way down now, coming off that peak.
I saw that's following the South Africa and a few of the other countries who peaked early. They're also dramatically dropping off at a great rate.
So they're talking about dropping all restrictions, maybe within the next few weeks.
Okay. Well, what it sounds like is we're finally getting to herd immunity effectively, and right or wrong, the vaccines have not prevented people from catching the next version of it, and so ultimately, I think we need to make a shift towards treating the symptoms as opposed to preventing you from being exposed to the virus, because there's no way to get away from it anymore. It's like the cold. It's just
a lot of the hospitalizations are the unvaxxed at the moment.
Right. All right, let's move on then. So we're going to talk about interoperability and cybersecurity. I'm going to spend a couple of minutes here talking about interoperability, and then we can have a discussion. And then Steve Fay is going to talk a little bit about the cybersecurity part from the specification. So just as a reminder, this is kind of our framework of how we're doing Division 2525, all based on the smarter stack, and with a section for each of the different layers of the stack, with another section for the interoperability of all of these sections, and a section on its own specifically on cybersecurity that's vertically oriented. So this is kind of the framework. So the way I certainly think about this is that if you think of a well-populated generic, let's say here, smarter stack. You have all of these different systems, and this is just a slide I took out of the standard smarter stack presentation. Really, what we're talking about is that all of these boxes really represent some kind of system, some kind of building system that's doing something, energy management, for example, analytics. And they may actually have multiple, and it could actually be a lot more complicated than this. And really what we're talking about here is how to make these systems work with each other. And the way to sort of depict that, it gets really messy, is kind of something like this. And obviously it doesn't look very nice, but from a digital perspective, this is not unusual. Complex systems are kind of like this, where essentially any two systems that have a need to talk to each other should be able to talk to each other to exchange whatever information that they need for the purpose that's defined for that building. Right, that's kind of how the stack works. And really, the way to think about this, because this, if you'd be sort of forgiven to say, if you look at this, it kind of looks complicated. But if you look at it with a filter of system of systems, it actually is not as complicated as that. And so this is really sort of the genesis of a system of building systems, which is really a system of systems architecture, but in this case, for buildings, right? Because these are all building systems, so it's really a system of all of these building systems working together. And that was the article that I wrote, and there's a link for it to it here. But really, so we've talked about this on private calls on Monday Live on and off for the last few weeks. But the question is, what is a system of systems? Right? Because it sounds kind of academic and it sounds kind of complicated. What is it? So there's actually quite a lot of work going on in the Digital Twin Consortium, because the DTC has deemed that system of systems is a key concept for digital twins. And so I was involved with a working group that I lead in a recent meeting in December to discuss this. And we came up with a definition of what a system of systems is, a SOS is. And the key two words here is it's a system of systems is a dynamic system comprising of interoperable constituent system. So the two the two important things is the fact that they're dynamic, and the fact that they are inherently interoperable, which actually makes them system of systems. And the other way to actually think about it is, what is different between a system and a system of systems, between a system and a SOS? And we worked on creating basically this very simple table comparing the two. And the top line is really, to me, from an architecture perspective, is really the most important. The connections between the constituent systems in a system, the connections are typically integrated, because a system has a very defined purpose. It has a very defined composition, right? If you the example we were using a lot in this conference was a Boeing 747 is an integrated system. It was built by a company to do a very specific thing, and that company, in this case Boeing, knows exactly all of the components that is needed for that system, and it's all very tightly integrated, and they all work deterministically by that single entity in a very controlled way, in a very predefined way. That's what a system is. A SOS is different because it's not like that. It's kind of fluid and loosey-goosey. That's kind of the way I think about it, not very technical terms. So the way that the connections really need to happen is that they need to be interoperable. The systems need to be interoperable with each other, because the composition is not predetermined. The completeness, what the system of system is, the completeness of it is never really known. And it's actually a collaborative thing that all of the different systems and maybe multiple entities actually put together over time. And I actually think this is, it was certainly for me a big aha moment, But I think it's a big aha moment for buildings, because I believe that we've been fighting and trying to think of the problem from an integrated perspective. And really what we should be thinking about is an interoperable sort of loosey-goosey perspective. That's not to say that there are no systems in a building, because if you take a control system, a Metasys kind of a system, or any of the other systems, that is actually a system. That is not a SOS. It's not a SOS, because it is tightly integrated. The vendor knows exactly or anticipates exactly what should be in that system for a particular building, right? So there's no vagueness in it. Whereas with a SOS, that's not the case. And obviously, one of the sort of the impacts of this is this whole notion of the way we do things right now with buildings is to actually construct the system, and then nothing happens to it after it. You know, there's going to the sort of the operational side of it. Typically, people don't think about that. So that's really sort of the systems approach. You design it, you write very detailed design specification for a system, and then you build it and you walk away from it. That's really sort of a systems approach. But SOS is not predefined. So over the course of the 20 years, it's going to morph and it's going to change. Somebody's going to install something, things are going to break, needs a change, et cetera, et cetera. So I kind of want to leave it there, but to me, that this was a big aha that I got in December, and would love to explore this further with this group.
Anto, what's the place of a system of systems in the world? You know, in our world, let's put it that way. Why do we look at system of systems differently than just a system?
What? I'm sorry, I'm not understanding the question.
I mean, like you said, we all understand what systems are,
Yeah,
and
yeah.
I kind of get what a system of systems definition is. What does that mean to us? You know, from the market that we deal in.
To me, the way I think about that, trying to think about that answer is kind of this, all right? I think we've been sort of educated, or we've been sort of we've grown up to think of a system as being something that we know everything about, and we must know everything about, and then we execute it, we implement it, we engineer it, and then it all works, and then we leave it alone, right? But when you start to think about some of these things and some of the use cases of, you know, what we were talking about earlier, IoT and sort of occupancy sensors and other sensors that come in and out of a building, right? And quite often I've heard even you, Anno, say that quite often you all of a sudden you discover there's a new IoT system in a building, right? And the way we typically think about it, how do we integrate that into the rest of whatever system we have? And I think an alternative approach is to expect that IoT system to be interoperable with the systems that we're actually constructing for that building. That then makes it, that makes the connection, making those IoT systems with everything else that we're doing a lot easier. I don't know if that answers your question enough.
The other comment I'd like to add to that too is there are other systems outside of the building. The grid would be a great example of that. And
Right.
when the grid hiccups, we need to all react, and we need to react quickly. And we don't really want to change any of our relationships in our systems, except what it is we have to do to react to the hiccup on the grid.
I really think I like what you've done here, Anto, a lot in terms of just defining the difference between the two. And the system of systems, to me, is largely illustrated by your diagram here, which implies a capacity to connect inherently. It's an inherent attribute of every system that it has the capacity to connect. And the challenge will be allowing that capacity to manifest without messing up the system itself. So one of the
Which
things,
system are you talking about?
any system. So whoever provides that system tends to want to put a box around and say, don't touch it because you're going to screw it up and create problems for me. And so yet in this dynamic world where, you know, things change and somebody has the idea, hey, I need to put in this tenant occupancy sensor system, you know, to know where everybody is, and so that I can do a bunch of other things that I have never done before. Well, in order for those things to be done that were never done before in an efficient fashion, that means connecting to, say, the building automation system and the lights easily, and do that in such a way that it doesn't mess up what's already working fine. So
Yeah.
those are the two challenges: is the inherent capacity, but do it in such a way that it doesn't restrict or compromise the proper functioning of the system as it stands.
Yeah, on your second point, I mean, you're right on both points. Well, on the second point, that's kind of the whole idea of the second word of the, you know, system of systems has two systems word in it, right? So it's got the first one and the second one. The second one is really made up of the constituent systems. So each constituent system is its own thing with very clearly defined boundaries, right? So, and the only way that system should interact with other systems within the system of systems should be with clearly defined interfaces within the boundaries.
Right.
Right. So that's kind of what system engineering is all about. Right. And so that's kind of one part of it. The other part of it is kind of the lines between these, because the lines are the use cases of when, you know, a lighting system needs to communicate with a integration system, and this particular line here. Right. So that's obviously in this sort of scenario, the architecture is calling for a mechanism of what we're doing with connection profiles, because that then clearly defines of how that kind of integration system can talk to that lighting system. So that's also defined. So each component is defined in terms of its boundaries, in terms of what it can serve and what it can consume. And then the connections between each of the systems should also be defined very, very clearly. So that, I believe, addresses both the points that you raised.
So, Anto, so do you then see this as being an overlay to an existing building operating system or platform that is already in an existing group of buildings? Or is this, how is this implemented, I guess?
Well, I would agree with the word overlay, except that I hear it quite often in different contexts. So I worry about the use of that word, but it is, I do see it's an overlay. It's not an overlay of anything other than awareness of what systems can talk to other systems and facilitating those connections. So it's not an overlay of function, it's an overlay of connection between
Connectivity.
systems. Yes.
There's a couple of questions on how this fits best with section 25. I kind of feel that it very quickly reaches outside of the 25 spec. What's your feeling on that?
Yeah, most definitely. As you pointed out, these systems can be outside, well outside. It could be well outside of you know, what could be what you would normally draw on a smarter stack. But really, if you go back to, you know, the basic sort of framework, really what we're saying is, really what we're saying is that there are going to be digital applications, right? That's going to need data, right? And if the data is such that any digital application can come along either before a building is built, or 6 months after, or 10 years later, or whatever, if a new digital application can come into a building, into the system of systems that is that particular building, and say, I'm an application, I can use this type of data, right, through its boundaries, then the data governance specification should be able to say, okay, there is that kind of data, and this is how you use it, this is how you use it securely, this is how you use it with respect to rights and privacy and everything else. All of that should be encapsulated in how the application talks to the data, and it should be done in a way so that each application itself does not need to understand every detail of that particular building, only the interfaces that he needs to get the data that it needs. It's not a he, it's an it. Just looking at some of the questions.
I think the drone example is an interesting one because each drone has a complex system to keep it flying in the air, and then it doesn't want to be messed with, but somehow they've created a way of having interaction with the drone next to it and controlling color and you know, all of the aspects. So just as a simple thing is like, how did they do that? I think we need to figure out how they did that, because I think that's important to us.
Yeah, it's interesting to think about comparison in nature to the drones, the Australian drones. It's basically like that. The drones is like a flock of birds, right? Right. Yeah. And the flock of bird has a flock of birds have a purpose to fly south or whatever, right? The drones have a different purpose, to entertain us, right? But the way they interact with each other is, I believe, sort of a system of systems approach. In the case of the birds, it's actually the minds of the birds that keeping it all tracked, that keeping all everything in proper order. In the case of the drone, is some digital system that's actually instructing every drone to be at the right place at any given time, with its relationship with this neighboring drone. I'm going to stop my share, and we can maybe move on to cybersecurity, and then we can come back to this, because I'm not sure this is completely done.
So you want me to go ahead onto and start on the cyber now?
Yeah, I think that.
Okay.
Then we can wrap the two up, and then.
Right. All right. Okay. So this is the same slide you saw earlier, just outlining the fact that cybersecurity covers the full stack, if you will, from beginning to end, or from the end to the beginning. So that's just the nature of cyber. And when you do any type of cyber, you should look to standards to help guide your approach. And in the case of what we're doing right now with this group, as well as the C4SB, is we've chosen to orient all of our efforts around the NIST cybersecurity framework. I'm not going to go into explaining what all this is, other than to say this is our guide to developing the requirements for cyber. Okay, so here's the empty stack, and I want to go through sort of layer by layer and talk through what goes where. So starting out, what are you trying to accomplish with cyber? Well, the first thing you want to do is you want to understand how much risk is associated with my particular building and the business I run in that building. Everybody's different. So some data centers obviously a lot more at risk with regard to the potential consequences of a cyber threat than is a small retail establishment in a strip mall. Okay, so you need to assess your business risk, and then within each individual system, you've got a system risk that you want to know what it looks like. And that's going to lead to defining policies that are appropriate for both, defining services that need to be put in place to keep that risk mitigated. And should there be an event, which even at all your best efforts can't preclude it from happening necessarily, you should have a communication plan in place to address what you're going to do on that unfortunate day when you find you got ransomware that just hit your server. Okay. On an operation level, up front, you should be establishing roles and responsibilities for both your internal employees as well as your third-party providers. So if you're relying a lot on your building automation company that installed the system to actually make sure that a lot of the things are being properly, a lot of the policies are being implemented properly, and systems are being upgraded with software and so on, then that should be well identified, and the services given out to the individual parties that are going to be responsible for making sure that things are done properly or in accordance with the policies. From a delivery standpoint, cyber is really about what goes on across the network or networks. So you have, there's a lot there, both from a remote standpoint and from an internal perspective. So how you design your OT network, how you install it, how you manage it, both internally and externally, how you control who gains access to these networks. There's a lot there on the OT network front. Then the applications themselves. Obviously, you need to know what they are and keep track of them, but then each application has configuration aspects to it that need to be set up properly from a security perspective. You need to put in protections like antivirus software, for example, and keeping operating systems properly patched. And then the software itself needs to be upgraded as security patches come out to, again, protect the application itself. From an exchange standpoint, getting back to the network again, ideally, you always want your network traffic itself to be encrypted. That's, if you think about what's going on with BACnet right now, BACnet SC is a big part of BACnet SC is to take it from being unencrypted traffic to encrypted traffic. But the traffic goes places, and we should be keeping good track of where it goes to make sure that there's not something unusual or unexpected, and that means monitoring your traffic. Data. The next level, besides encrypting the traffic once it goes over across the network, wherever it resides, ideally, again, encrypt it at rest. And then be in a position where you're able to identify data corruption and, if necessary, remediate it. The systems at the system level in the BAS system or in the access control system, there's a whole nother level of password management that goes on that's above and beyond the password management that goes on at the network layer. And so you need to manage all those passwords very precisely according to policies that you set up at the very top here. And then you also want to, that's typically where the logging is lives, and you want to be able to set up logs and archive those logs such that if there is an event, you've got records to go look at to see what might have happened. And then physically, the system should be in a secure location, and there should be some keys or access control that restricts who gets to actually go in and gain access to the control systems themselves, so that these are only authorized personnel. Now, across the applications, technology is backup and restore. So it's not, there's configurations within the network that need to be backed up. The applications need to be backed up. The building automation system itself, and again, any and all these different layers need to be restored at various times. And then finally, disaster recovery. Well, when that happens, it affects everybody. It affects the operations and so on. So you got to be looking across everything at the time when you're trying to recover from a disaster event. So this is how we're thinking about looking at cybersecurity using the stack. Now, going from this to an actual specification, what we've developed now is a series of specifications that are paired with the risk profile. And we've said, hey, not every building's the same. So we've got basically 3 different risk profiles, from a very basic risk profile that we call essentials, to a comprehensive, to a security in depth. And within each one, following sort of the CSI model, in the general specification, general portion of the spec, you define what is your risk profile, who's going to do what, make sure everybody's got proper insurance, and that you're in compliance with the recognized standards. And then you have your policies. And again, the policies, we have a set of default policies that cover all of the topics you see here, and they can be modified to meet specific user needs and desires. but we're providing a complete list of standard policies. And then finally, on the execution side, there's two parts. There's commissioning it at the time you turn the system over, and then there's the ongoing services. And this is the maximum list. Not all of them obviously are required in a simple situation, but these are the types of services that should be considered in any kind of a cybersecurity deployment. Take the words and turn it into something visual for you guys to look at. Let's just look at this full architecture here, and I'll just quickly run through what essential. For example, when you start out with essential services, you're starting about remote management for all your remote users, your management of your users locally in the system itself, making sure your servers are properly backed up, and that you maintain your software. Those are sort of the starting point for any system, and all systems should at least be doing those four things if they want to secure the system properly. If you have a more complicated system with multiple OT systems over tens or hundreds of IP nodes, you're going to want to manage that on-prem network very precisely. And then your servers are going to be even further managed with antivirus protection and patch management, and making sure no non-application applications show up on that server. So it's got to be a lot more aggressive, both on the network side and on the device side. And then for the security in depth, you want to be monitoring and making sure all your endpoints are properly protected, that you're monitoring the OT network continuously for traffic and for any kind of vulnerabilities, which you can do through continuous scanning of devices to make sure that they're all up to the latest software revs. And even once a year, come in and do penetration testing to make sure that people from the outside can't get into this system and do all the bad things that we're concerned about. And then finally, have some means by which all of this monitoring is looked at on a regular basis in what they call a SOC service. So this is the full picture, if you will, for what cyber would look like as you implement it across an OT environment.
Thank you. So, thoughts?
Security is hard.
Yeah, exactly.
Much of that, can you comment on the status of the security component of the 2525 specification, now that you've given us kind of that overview of all of those components?
Yeah, well, the spec itself, John, is done. I'm ready to share it with any and all for comments. So I've got actually 3 specifications: one for essential, one for comprehensive, and one for security in depth. So it's reached that point, and so yes.
So our goal, just to continue on that point, our goal has always been to have an initial version of this 2525 spec by AHR, which is 2 weeks away.
Mm-hmm.
We'll probably spend next Monday live show talking about the sort of the deployment part of all of this and how we're going to bring it all together. It's not going to be finished by HR. This is kind of our first draft, as it were, that we want to socialize and get feedback. And that's the reason why we're also doing this month. So.
Be interesting to get a Verdantix comparison on. Mark was talking about the occupancy sensors and things, but interesting to see what Verdantix would make of how many people have actually deployed or picked up on cybersecurity. Bearing in mind, it's probably got as much bandwidth and talking about as occupancy, and how much has been really deployed or just been lip service at the moment.
Yeah, that'd actually be a really interesting survey, Roger. And I think there was some done several years back, but not a lot of current stuff that's out there on the market research. I think, yeah, to your point, there's been a lot of conversation and lip service about that. And I know that, you know, people like Bill is doing a great job, you know, getting out into the marketplace and having people understand what the challenges and the issues are. And, you know, and I think we've come a long way in solutions as well, you know, that didn't exist. But to your point, are people really taking attention of it, right? And are they doing things about it?
I think it's a continuum where large, sophisticated customers have a start. You know, people have been using virtual private networks or other kinds of technology for more than 20 years to secure things. But I think that generally speaking, the level of policies and procedures that Steve is bringing to the table here have not been implemented, especially in OT. And at the same time, we're moving very quickly in the BACnet community to bring along BACnet Secure Connect and the Managed BACnet program, which will be our industry's answer to a lot of the technical components that are needed to the solution.
Yeah, I want to pick up on a question. There's a question that Ernie Beck asked about the examples of 2525. We don't have any examples. This is still work in progress. So what you see here and what you see next week is all there is so far. And the intention, the reason why we're doing all of this is to open source the work product that's the resulting of all of this work. Just to clarify that, because Ernie asked specifically about those. Sorry, I know.
And then to
No,
Steve's
it's
point,
fine. I was just, sorry, go ahead.
I was going to say,
I'm out.
or Anno, to your point, I'm looking at something right now that says OT cybersecurity solutions currently in place at facilities. Globally, it's 44%.
Okay.
US 48%. So again, with the importance of cybersecurity, especially the panelists and the group on here, I guess my question to the group is 44% low in your estimation?
I don't think it's a realistic number. As I said, I think it's a continuum. I think people do generally a very crappy job of this, Mark. So people that say,
I agree with you. Yeah.
I would, it's a
Not
little
take
bit,
it very
it's all about
seriously.
definition. It's like the occupancy
right.
sensor. What's an occupancy sensor, and then what's cybersecurity compliance, or I really question it.
I think it's probably more like 10% of the people have their act together at any given level.
Yeah.
When you think about the amount of time that Shodan's been out there, just that kind of raised a flag about all this, you know, that's
right.
a lot longer than occupancy sensors.
You know, what I find interesting is, you know, there's tremendous rhetoric around cybersecurity, and we're up to our ankles in it, but there's no money yet. Just like many things in our industry, there's no money to pay for any of these things, and that's a necessary requirement. You know, if you look at the huge amounts of money that are spent in IT compared to what's spent in our industry, you know, one of the reasons it's a no buck Rogers problem right now.
Yeah.
But
so Jim, to your point, if I could, the reason I wrote the spec the way I did in the execution part, and when I spell out the services, is to force that conversation.
Right.
And in the spec, there's a matrix that gets filled out, and it says who's doing what. And so it basically forces the owner / engineer to say, okay, the software upgrades, that's going to be done by the systems integrator. It could be the remote, you know, the remote access management, that could be done by any and all these things potentially could be done by third parties. And because until we force the conversation, it's never going to change.
Right.
In my opinion, right? So, which is why I'm making it part of the specification that you actually specify who's going to do the work to keep this thing secure. It doesn't happen by itself, period. Yeah. And
then Jim, I agree with what you just said, Steve. And then Jim Lee, isn't the risk greater in a cyber instance to overcome what you just said previously? as far as there's no money or, what you just said?
Yeah, so are you basically saying, Mark, that we're waiting for a cyber incident to get people's attention so we can get this funded?
Not waiting. I mean, we all know that there have been cyber instances within in our space, but has there been one in which life and limb has come out in public? No, there hasn't.
Absolutely not. Exactly.
Yeah. And, from this astute group, is that what it's going to take? Somebody to physically, unfortunately, get hurt?
But that's a generic
wake up?
statement. But that's a
Say
generic
again?
statement for security, any security, right? I mean, home security. The guys are really good at showing people, breaking in into your house.
Of course. I think we just lost Anna.
We just lost Anna.
Yeah.
Right.
There he is. He's back. He's back. Good.
I sort of worry about sort of waiting for that sort of cybersecurity event to happen to wake us all up. I worry that it almost needs to be like a really, really huge event, and I'm not sure we want a huge event. I don't know.
Well, I think, Anto, a lot of us in the field are working diligently, on the subject matter. But, once again, if there's no money to pay for things that cost a lot of money, that's a challenge that's very hard for us to overcome. So I'm sure we'll continue to work towards that goal. And, I think as an industry, from a technology standpoint, we're moving along very quickly. And I think in a couple of years, we're going to have a nice closed-ended solution for zero trust security for building automation devices.
Right.
That said, it's, as Steve points out in the spec and other places, this is a process with many, many moving pieces that are over and above the technology. That's what we need to fund. And the training, the rollout, the ecosystem that's needed to support that is a big, expensive deal. And I don't think you get the whole package until some really big shoes start to drop. But we can move towards it.
Yeah.
Well, I think also wrapping this up into Steve's work and wrapping this up into the 25-25, I think is a crucial piece too, right? Because rather than dealing with it as an adjunct or a later thought or an add-on thought, if we're going to talk about smarter buildings, part of the paradigm of a smarter building is it's more secure. Security, secure building is as much a part of a smarter building as anything else, right? I mean, it's a step on the spectrum that Jim just talked about. So I think it's crucial that it's part of the deck.
Or pharma as examples. The same thing is definitely the case with cyber. So if you're working with a data center organization right now, data centers are very cognizant and very concerned over cybersecurity risk. They have policies that they want you to comply with. They spend money on it because it's a data center, right? And so but so much of our business, particularly on the commercial side, they're very indifferent about it overall.
Right.
Yep.
I agree completely, Steve. It's going to be uneven. The people that care about it are going to spend the money first.
Right.
And but rank and file, I think it's going to take quite a long time before it gets out there in force.
Yeah, which is why I'm advocating for a tiered approach that says the commercial stuff, here's some basics. Doesn't cost a lot. It's like a very inexpensive insurance policy, relatively speaking, right? Do your backups, get your remote access under control, and keep your software up to date. Bang, do those three things. It's not going to cost a fortune, and yet you're going to be a whole lot better than what you are today.
So David Katz just posted a question about resiliency, and this reminds me of some of the sort of interesting work that's going on in the DTC and the Digital Twin Consortium on cybersecurity and also on system of systems. So it kind of ties these two things together, but it also ties in another aspect of large complex digital systems, which is trust. right? Which is, how do you trust when you have a system of systems and you're getting a piece of data from another system that you've just connected to through some interoperable mechanism? How do you trust that data? Where did it come from, right? And how resilient is that data and everything else? So the work is going under the name Trust Vector. So what this group is doing, I'm very involved with that, is creating basically a mechanism for Trust Vector. And Trust Vector, a trust in this term has actually 5 attributes to it, 5 dimensions. One is security, which means cybersecurity, privacy, resilience, reliability, and I've forgotten what the fifth one is. I'll look it up. Anyway, there are five things. Resiliency is definitely one of them. So the whole idea is that within a system of systems, you can exchange this trust information, which is in a way unrelated to what the things are actually doing, right? You don't care if it's a robot or if it's a fan on a HVAC system. You want to be able, all of the digital systems in a particular context, in a particular building, to be able to exchange information about the trustworthiness, so that when a piece of data comes from somewhere, then you can actually know about that. But again, trust means security and resiliency and privacy and reliability and other information. So it's a little bit early to actually get too deep in this, but it's kind of an interesting way of actually bringing all of these things together.
It is a hard theoretical problem, though. I mean, in the context of, who establishes and controls that trust when, the assets that we're dealing with in these systems of systems are changing hands. What happens to the security certificates when somebody sells the building? When it's an installer installs the system, do we have trust on first use, so that there's sort of the implicit thing that when somebody's designing and building the system, that they started it up? I mean, this really, these are challenging computer science problems because they touch so many different components. So, you almost need to have a context for the solution space that you're solving for there.
Yeah, that's I won't dive into much detail, but there's a lot of thinking around those kinds of issues, Jim. You're totally right.
And then just add a dimension to that, again, why I think this is why it's a good thing that we're including it in 25, because one of the areas that I've got a bigger concern for is not just the legacy stuff, but all the new IoT solutions that are going out there and in there. I've seen several of them, and they've got such a weak security models that they've thrown together, that to have something like this in the 25, I think adds to the building owner's ability to talk about, okay, if I am looking at just as an IoT solutions, what's the security infrastructure? What template can I use to measure that? And I think this is a great fit for that, and as part of the smarter building thing,
Okay, we're coming up to the top of the hour. Anyone want to wrap this up, what we've done here? Steve, you look like you're trying to say something. But that's fine.
No, I'm good.
You're good.
Yeah.
My only comment is I think I like the system of systems discussion. I think we've only just scratched the surface. I'm not sure if we need some more discussion on that.
Yeah, totally right. Totally right. And it's not just us, and it's not just buildings on that question. It's actually it's a very, very big question because of the complexity of a lot of different systems. So
yeah. So Andrew, I'll circulate the 3 specs to all the panelists here, and then we can maybe talk about it on Wednesday, when and how we, go public with them.
Yeah, and then we'll I'm sure we'll talk about that, and how all of these different pieces are, how this group is thinking about deploying all of this. That'll be the focus of next week. So with that, let us bring this to a wrap. Thank you very much for all of your contribution. Thanks the attendees for being here, and video of this will be up in the morning. And I hope you all have a great week, and we'll see you next week.
Okay.
With that, bye-bye.
Sure.
See you guys.
Bye.
Thanks.
Yes.
Bye now.